Okay. Okay, so for our problem number 3, hanapin pa rin natin yung IB, IC, IE, and the collector to emitter voltage. Okay, so yung circuit, kapareho lang to ng problem number 1. But this time, dinefine natin yung value ng VBE on, okay, nakaspecify siya as 0.9 volts, and si VCE sat, nakaspecify siya as 0.3 volts. Okay, now, dating gawi. Umpisa kapag magsosolve tayo ng circuit, umpisa natin sa pagsosolve ng the collector saturation current. Okay, so maglulup ulit tayo dito sa output side, okay, or sa right side, kung saan dadaanan si collector to emitter. So, tatawagin natin siyang loop number 1 by KVL, and loop number 1 by KVL, makukuha natin VCC pa rin minus ICRC minus VCE, that is equal to 0. Okay, para makuha natin yung IC saturation current, isa-substitute natin sa VCE si VCE saturation. Okay, the collector to emitter saturation voltage. Okay, VCE sat is a primary constant, which is kapag hindi siya given, gagamitin natin yung default value. But this time, given siya, kaya ang gagamitin natin is 0.3 volts. And to solve for IC sat, okay, mamanipulate pa rin natin tong equation na to, transpose natin tong ICRC sa kabila, magiging positive ICRC siya, and then divide natin both sides of the equation by RC. So makuha natin IC, okay, or IC at saturation is equal to VCC minus VCE sat divided by RC. And by substituting the values, makukuha natin VCC, okay? So 12 volts siya minus VCE sat na 0.3 volts divided by IC, okay? IC sat, or divided by RC, that is equal to 2.2 kilo ohms. So makukuha natin the IC saturation current is 5.318 milliamperes. Okay, so take note also na hindi ito yung final answer natin, okay? Ginamit lang natin to, sinolve lang natin to para safe tayo mamaya sa pag-compute ng mga final answers natin. Okay, so to get IB, okay, maglulup ulit tayo sa input side para makuha natin input parameter, which is IB. So, tatawagin natin siyang loop number 2 by KVL, and loop number 2 is VCC minus IBRB minus VBE, that is equal to 0. And VBE is equal to the VBE on, okay, a primary constant na this time meron siyang given na 0.9 volts. So makuha natin by manipulating the equation, makuha natin IB is equal to VCC minus VBE on over RB. And by substituting the values, makuha natin 12 volts minus 0.9 volts divided by RB na 470 kilo ohms. Makuha natin 23.617 microamperes. So, medyo nag-vary siya, no? Medyo bumaba yung value niya compared sa problem number 1. Okay, and to get IC, okay, try natin yung transfer function, which is IC is equal to beta IB. Now, gagamitin natin yung transfer constant na beta. So, substitute lang natin 100 times the value of IB, which is 23.617 microamperes. Okay, so ang magiging value ng IC natin is 2.362 milliamperes. And again, to get IE, okay, magki-KCL ulit tayo. Okay, ang current entering dito sa BJT is, kapag NPN transistor, ang current entering is IB and IC, while the current leaving is the emitter current. Okay, so now IE or the emitter current is equal to the sum of IB and IC. And substitute lang natin. IB is 23.617 microamperes plus the IC which is 2.362 milliamperes. So makukuha natin sa IE is 2.385 milliamperes. Okay, so check pala natin, no? Si IC is less than the IC sat. Therefore, tama to. Okay, so and since hindi siya sa saturation, para ma-solve natin itong VCE, gagamitin ulit natin itong equation na to, yung equation 1. So, transpose lang natin yung VCE sa kabila. Makukuha natin VCE is equal to VCC minus ICRC. And that is equal to 12 volts minus IC, that is 2.362 milliamperes multiplied by RC, which is 470 kilo ohms. Okay, so makukuha natin the value of VCE is equal to, okay, correction pala, no? Hindi siya 470 kilo ohms, 2.2 kilo ohms siya. Okay, and the value of VCE is equal to 6.804 volts. Okay, so here are our final answers. IB is 23.617 microamperes. IC, okay, by using the transfer function, 2.362 milliamperes, which is less than the IC sat, so tama yon. And the value of IE is 2.385 milliamperes, while the value of VCE, medyo nagkamali pa tayo kanina, 6.804 volts. That would be our final answers.